John, remind me what is it on Linux? I think you gave it to me on Linux. Can you put that in chat for me? Or
IP address?
IP adder. What was the rest of that?
It was IP address.
Oh, that's it?
Yeah.
See, which is a command, just like that, right?
IP space address.
Oh, okay. I know there's an IP adder command. This does not work on Mac. Oops. See, oh, wait a minute, it does. Interesting. But it doesn't give me the same information. Okay. Can you get the lifetimes with that, John?
It does tell you what the address is.
But I mean the lifetimes?
Whether it's temporary, whether it's deprecated.
Yeah. Okay. It doesn't tell you the lifetimes.
I
remember you showed me that.
Let me check right now. I'm on a machine.
John is the Linux expert. We Linux, Unix worked together at SCO. He was one of the go-to people when we worked together at Santa Cruz operation. So as some of you know, I've used John for help. He actually taught Unix here years ago for us part-time. So I've known John for many years.
It does give you the lifetime.
Okay. Just doesn't for on Windows or Mac OS.
It's, for example, it has 12,576 seconds.
Okay.
Or 14,195 seconds for the various addresses.
So, the Mac OS uses a flavor of Unix that is slightly different than Linux. So things are sometimes a little different. I will say, I really enjoy what Mac OS has been doing with IPv6 and the support of it with some of the commands. And I'll show you some of these. You'll see a couple of them today. But the ifconfigs-l gives me the lifetime. Now, I'll show you how to do this on Windows. Also, I've got that coming up. But what we're looking at here is these lifetimes. And PL is preferred lifetime, VL is valid lifetimes. When we take a look at this, we're going to take it fairly slow because we have two different addresses. We have the temporary address and what we call here it says secured. No, that's public, permanent, stable address. So let's get into it. Instead of me just talking about what we're going to talk about, let's talk about it. So here's the difference between IPv4 addressing and IPv6 addressing. With IPv4, it's fairly straightforward, right? Use static or DHCP. That's about it. And DHCP, you have one IP address, and that's it. Oh my goodness! With IPv6, you have all these knobs, and with all these addresses, you have all these different variations that can happen. And I'll talk about what I mean by that, because some of the variations come from the router advertisement, some are up to the operating system. And you've got to figure both those pieces out to really understand what's happening, if it even really matters. So let's get into it. So it's just how much into the weeds you want to get into some of the stuff. I know enough about electricity so I can plug in my light, my computer, my whatever, and, I get power. I also know enough about electricity where I'm not going to put my finger in the socket. Okay, that's not a good thing. How it works and all that, do I need to know? No, but I'm good with what I know. And that's where we get with this stuff. So I'm not going to try and overwhelm you, but some of this will be a little just like, wow, that's going into the weeds. So let's take a look at stateless address auto configuration first. Okay, the whole idea of stateless address auto configuration is that we don't need a stateful DHCP server. We have a router that sends out a router advertisement message. sends it to all IPv6 devices multicast, which means any device enabled for IPv6 is going to listen for and process these messages. So we'll accept this IPv6 packet, which is encapsulated in an Ethernet frame with a MAC address that it's also, this NIC card is also accepting. Now it's coming from its link local address. We'll see how that's used in a moment. The router advertisement message includes, hey, this is the network prefix we're on. Oh, and I already made a mistake. Oh, Rick, don't look. Yeah, I changed this. I changed this to show you the address here at school. And that's what always happens. I copy something and change. All right. So it's going to advertise this prefix. This is actually my home router, excuse me, not school. This is my home router, Comcast. So this is the prefix that's been given to me at home. By the way, nobody else has this /64 prefix but me. And it's unique in the internet and it's globally routable, right? No NAT needed. Okay, that prefix is going to be advertised in the router advertisement. It's also going to include a DNS server for me to access. And let's say the auto config flag is set. That means stateless address auto configuration. So what happens when these devices get this router advertisement, they see the prefix, they go, great, we know what network we're on. They see the source IPv6 address of the packet, says, oh, that's my default gateway. This device will go, yep, I'll include that as my default gateway. That's my way out of here. All right. Next, it says, oh, DNS server. Okay, great. We now know who to ask when we type in www.amazon.com, get the IPv6 address. So all of this, actually, this kind of information, by the way, is called stateless. Stateless in the fact that nobody's keeping track. Everybody gets the same information. Now, the A flag has been set. What that does is that tells the devices to use SLAAC, stateless address auto configuration. What they're going to do is they're going to grab this prefix, put it here, and then create their own interface ID. Okay, now we're going to use a random 64-bit value, could use EUI64, the MAC address. Same thing here, it's using a random 64-bit value. And I'm showing that because that by far is the most common now. Client operating systems are not going to use EUI64 unless you configure your operating system says, I want to use my MAC address. And you can do that if you wish. Okay, so the important thing here is no stateful DHCPv6 servers needed. Nobody's maintaining state of who has what address. Okay. Now we'll see that before these devices use these addresses, even before they use their link local address, they will actually do something called duplicate address detection first. So these addresses are actually put in tentative state. We'll talk about this in a moment, but since I'm there, the tentative state means I'm going to, before I use my link local address to communicate with anybody, before I use this address to communicate with anybody, I'm going to send out similar to an ARP request. Hey, who out there is, it's this address here, global unicast address, whoever has it, send me your MAC address. That gets sent out as a all IPv6 multicast address, similar to this, right? All IPv6 devices. So everybody will see it. Won't go past the router. Won't go past the router. But everybody here will see it. Everybody will go, no, not me, not me, not me. And then when the PC doesn't get a response or reply, it says, okay, it's unique. I can use it. Is there a chance that it might get a response? Go, yes, I have that address. If you're creating it yourself, very, very unlikely. Could it happen? Yes, but it's very unlikely. All right. Yes, thank you, John. Yeah, Mac OS uses free BSD-based Unix. So we saw that, it's not using EUI 64. Okay, and that's because, users, operators, the companies, they have concerns about if we use the MAC address of the NIC card to create our interface ID, okay, no matter what network you're on, you can be tracked. I mean, 48 bits, what is that? Say 32 bits is 4.29 billion possibilities. So 48 bits is going to be, one in whatever. And so chances are this is going to be unique no matter where you are in the world. So basically, it's an issue with privacy. Being able to track a single user no matter what network they are on. Oh, that must be the same computer that was Cabrillo, that was at Rick's home, that was at Rick's Cafe. So here's actually from the RFC, that 4941, that talks about privacy extensions for stateless address auto configuration. So there's SLAAC, stateless address auto configuration. SLAAC, let me just back up here. That just says, hey, devices can create their own interface ID, and they can use random or EUI 64. What the privacy extension does is going to add a couple of things that we're going to talk about here. But this is right out of the RFC, so let me read it real quick. It says, for example, a network sniffer like packet tracer, like Wireshark, placed strategically on a link across which all traffic to and from particular host crosses, and that could be wired or wirelessly, could keep track of which destinations a node communicated with and at what times. Such information can, in some cases, be used to infer things, such as what hours an employee was active, when someone is at home, and so on. Periodically changing the interface ID, so even on your own network, of an address makes it more difficult for eavesdroppers and other information collectors, such as websites and mobile apps, to associate these different addresses and transactions to a particular device. And not only on that network, but if somehow they see your IP address, like a data broker, on different sites, then they can kind of put all that together as coming from the same device. Okay, let's talk about what this RFC gives us. Privacy extensions. Okay, first of all, it means that the operating system, and this is up to the operating system, can use randomized interface IDs. Okay. So that's creating an interface ID that's not traceable to the physical device. You can have random 64 bits. Also, adding a temporary address. Okay, this is where we're going to get into public and temporary addresses. Additional addresses that have relatively short lifetimes determined by the router advertisement, but really, as we're going to see here, determined ultimately by the operating system of the client. Okay, these are used as a source address when originating connections. So let's take a look at temporary address. Temporary address is what we use whenever we're connecting, when we initiate the connection, like going to Netflix. Okay. Now there's another address that we can use, and this is an option. Doesn't have to be used, but both Windows and Mac OS do this by default. They generate what's known as a public address. So you notice I have two addresses here. I'm at school right now, and I have a temporary address, and I have what's known as secured, also known as stable, public, and permanent. Now, what is that for? That's an address I have that if I'm somebody else, me or somebody else, is away from my network, and want to be able to initiate the connection from outside, I can use that public address to access that device. Okay, now I've got to open up my firewall to say, yes, I want to allow those connections to come in. A lot of times by default, your home router will only let things come in that were initiated from the inside. So only things from the outside can come in that were initiated from the inside. But if you're trying to initiate something from the outside to come in, then you got to open up that your firewall. You've got to allow that to come in. So this is known as a public address, stable address, a permanent address. Okay. So this is not, and why is that called that? That's because that's an address that will rarely change, if ever. It's basically going to be up to, everything's going to be up to two things. It's going to be up to your router's router advertisement, making the suggestion, and ultimately up to your client operating system. We'll take this slowly here. The public one is the most easiest one to understand, but let's take a look at SLAAC here now with stateless address auto-configured with privacy extension. Okay, and Rick did it again. See, this is what happens when Rick copy and pastes. There we go. All right. So we're going to send out the router advertisement. This is so what you'll be seeing here is both stuff from home, my house, and at school. And the reason I'm showing two is because there are two different approaches by the router's router advertisement. But my Mac, my operating system, and my Windows operating system at home, it has the ultimate decision. So let's take a look at this first privacy extension. What happens? There we go. Sending out the router advertisement, all IPv6 devices from that source IPv6 address. Here's our prefix once again, nothing new. DNS server, nothing new. Auto config flag, nothing new. Okay. There's our network prefix. Okay. And there's our source IPv6 address as our default gateway. Still nothing new. Now, it just so happens both these devices here, and actually I believe I'm using one is going to show you my Windows, what it did on Windows, and one on Mac OS. But they're both operating systems, client operating systems by default enable the privacy extension. Okay. That's really the way things are now. Okay. Is that all recent operating systems are going to do privacy extensions. Yep. And you can disable that, by the way. You can do all those knobs, okay, on your operating system, whether it's Windows, Linux, or Mac OS. Okay. But let's stay with the defaults here. Okay. DNS server. All right. So auto config flag. The device will create a public IPv6 address and a temporary IPv6 address. Notice two different interface IDs. Same thing here. A public IPv6 address and a temporary IPv6 address. Looking at this looks like my Mac down here. This is my Windows PC up here. Now, just a point, I didn't do this, but typically your link local address will typically have the same initial random IP interface as your temporary address, but that's not important. Okay. So we have two addresses now. Okay. We have a public address and a temporary address. Just to be clear here, let's remember that the public address is not meant, we don't worry about privacy. We don't care how often it changes, if ever. Matter of fact, maybe we don't want it to change. Maybe we prefer that to never change. And one other note, we can, if I'm really, well, let me I'm going to bring it up here in a moment. Stateful. So again, no stateful DHCP v6 server needed. Let me back up a little bit here. One other thing, that private, here we go. So this is how our public address is going to be used here. Okay, that it generated the random 64 bits for the interface ID. Okay, and we don't care if everybody knows about that. Now, you may wonder, well, could I just create on my computer another address, a static IPv6 address? Remember, in IPv6, you can have as many addresses as you want. And the answer is yes. You could actually just, if you wanted to statically configure another address that with your prefix, your network prefix, and an address of your choice, and type it on that computer, make it a static IPv6 address. Sure, people from the outside could access it. No problem. No problem. Just tell your firewall. This is just doing it automatically for you. Okay. Does that make sense? And let's remember, most users are never going to need to do this. Okay. This is why your firewall blocks these from coming in by default. All right. So once again, we get back to here. All right, we have public and temporary addresses. So this is actually looking at my Windows box. Okay, you'll see here, and I'll explain this other one as well. So here's my public IPv6 address. Okay. And as we'll see, this one, has a long, we can say, lifetime, and almost a continuous lifetime. Okay, we don't really care if this ever changes. This is a temporary IPv6 address here. This is the one where my operating system wants that to change. It's going to help protect me. My operating system is going to look out for Rick. Now, if we come down here, this is the command on Windows that can show you the addresses and their lifetimes. We're going to talk about these lifetimes and where this comes from. Okay. Notice 4 minutes, 59 seconds. Okay. It's actually at home. There's a countdown starting at 5 minutes. I'll talk about that in a moment. But you can see my public IPv6 address and my temporary IPv6 address. Now, where did this address come from? Same prefix, same network, then :37F what? Where'd that come from? Over here, DHCP. So we'll be talking about this next week. DHCP server. Yeah, or no, actually, I think we talked about, what day is this? This is Tuesday, right? Thursday. We'll talk about DHCP. The router advertisement message from my Comcast router actually also says, Rick, the A flag is set, create your own addresses, okay? Have your own temporary address and public address, the A flag yourself. But it also sets what's called the M flag, the managed flag. It says, hey, by the way, I'm going to act as a DHCP server, and I'm going to allocate you an address. So why don't you'll have to ask me, and then I'll give you the address just like a DHCP. We'll talk about process and IPv4. We'll talk about that on Thursday. So this is a stateful address. It's keeping track. Now, this address, could I allow somebody from the outside access to this address? Certainly. Just open it up in my firewall. Okay. Now, why does Comcast do that? There's really, I haven't really gotten a good answer, except why not? It doesn't hurt anything. But we'll talk more about DHCP Thursday. All right. This is my my Mac at home. Okay. Again, same Comcast router. I'm getting the same network prefix, getting a different interface ID. Okay, has a public address, temporary address. Okay, you can see I'm trying to color code everything here. Public, temporary. All right, let's get into this a little bit more. All right, so let's take a look at SLAAC with the privacy extension. Okay, so it all begins with the router advertisement message. Router advertisement message sends out a prefix and prefix length. This prefix is going to be used to create a public IPv6 address. And the interface ID can be EUI64 or a random 64 bits. This is up to the operating system. Okay, your client operating system is going to choose the random. And I put this little asterisk here because this is what the privacy extension says. Privacy extension says, I really recommend you make it random, and which your operating system will. Okay, now what else will be done? So this is, it will also create a temporary address. Okay, so the temporary address, the interface ID has to be random for the temporary address. I mean, that's the whole idea of having the temporary address, because it's going to change. Okay, the only thing it can change is the interface ID. Makes no sense to, hey, let's keep on changing our temporary address using our MAC address. That's never going to change then. Okay, so it has to have what's going to change is the interface ID portion has to be random because that's what's got to change. Okay, again, privacy extension. And whether or not, although it's, you know, the RFC says to have the privacy extension, you don't have to create a temporary address operating system. The operating system goes, wait a minute, this is the whole idea of having privacy, is to make a temporary address. Of course, I'm going to create a temporary address. So it's optional per this RFC, but your operating system is going to create a temporary address. Now, these are relatively short lifetimes. These can be as long as, you know, we don't really care. Okay? Hey, forever, as far as I'm concerned, I don't really care. This is what, especially the client operating system looking out for you, wants to keep this random. And this kind of gets into the weeds a little bit, but it may just do whatever that operating system, you know, sometimes it just says, hey, this is long enough, I'm changing this. Okay. So we'll talk a little bit about this, but this all comes down to what we call the lifetimes. The lifetime of these addresses. Basically, how long can I use this address? And by the way, who determines this? Well, the router advertisement contains two lifetimes: valid lifetime and preferred lifetime. Now we're going to get into the difference of those in a moment here, but not right away. But for the public address, your permanent address, the one that you really don't really care, who knows how long it's there, whatever the router advertisement says, we'll keep it as long as that. And we're going to see that, you know, it's a long time. But for your temporary address, you know, the operating system is going to be in charge. Now, it may say, hey, you know, whatever the router advertisement suggests, I might go with that, depending on what it suggests. The operating system might go, you know, I may do my own thing. And it may even depend on what the value is here. If your operating system, like Mac OS, looks at this router advertisement and goes, you know, that's a little long for what I like to have for temporary addresses, I'm going to shorten it. Or it may look at it going, yeah, that's okay. Really, it's like your operating system has a mind of its own. It doesn't, okay? But it's not like it's doing this on, you know, randomly or on the fly. It actually has, the operating system is is programmed, coded, so that it looks at certain criteria and says, okay, this is how long I'm gonna keep this temporary address, and then I'll create a new one. And we'll look at that process here today. Okay. So we have two addresses. This one again, hey, stay out there as long as you need to. I don't really care. Okay. Yeah, I prefer random. I don't like anybody knowing my MAC address that doesn't have to, unless you're on my network or, I don't know, but outside where you don't need to keep, I want to remain, again, same kind of thing. If my public address used EUI 64, wherever I am in the world, it would be able, anybody would be able, maybe I want that. Maybe I don't want that interface ID ever to change. I don't know, but let's go with random. Definitely temporary address, we want random. We want that to change. All right, so again, public address. Yeah, how long should I keep that address public? Whatever the router advertisement wants. As far as temporary address, I have my options. I'm going to be looking out for you, the user, on this. All right, so again, here's our two devices on that network, and I won't change this right now. Again, okay, this network address, okay, and notice that they all have, two different addresses here, two different addresses here. Public address we're going to see, also known as a stable address. So that's a good way, or permanent address, okay? Want to kind of keep that fairly stable. I like that term stable more than, the reason I use public is because that's what Windows always showed it as public. And anyway, I won't get DRCs. Okay, public address here, permanent, stable. All right, let's take a look here. Let's look at that public address. In this case, the router advertisement determines this. Okay, gotta move my computer over a little bit so I can see. All right. So let me just show you here on my computer, right here, what we're talking about is this address right here. This is my public address. Okay. Matter of fact, this was my public address this morning. Okay. Look at, and so this is Cabrillo's. Let's kind of make sure so I shall be using my Comcast router, but just to show you here, this is Cabrillo. This is my network. Okay, yes, I'm in 828 network. This is my interface ID. And just look at 26BE. This is what I was this morning when I came in, my public address. This is what that address was yesterday. Where is it? Same address. Here's it public right here. Same address. See that 26BE? Didn't change. Okay. And it's been that address for weeks, months. I don't know, since maybe we rebooted the router. Okay, so let's take a look at how this public address works. This is I'm at home. This is the prefix. Now, I want you to notice the valid and preferred lifetimes of Comcast. Very short, and they use the same for both. We'll talk about that more in a moment. 300 seconds, which is 5 minutes. Okay, doesn't seem very long, does it? Okay. So the router advertisement goes out. My Mac, my Windows device receives it. Okay. So the prefix is advertised by the router advertisement. The clients are going to use this prefix to create their own public IPv6 address. So let's do this. Let's grab this prefix. Okay. And create a random interface ID. Okay. Did we do that? Here's the prefix. Here's the prefix. This is, nobody else in the world has this. Okay. That's my network. Here's my interface ID that my In this case, it was my Mac, created this randomly. Okay, everybody okay with that? Everybody good? I'm going slow on purpose. Everybody good?
Wait, this is slow, Rick?
Oh, I'm sorry.
No, I'm teasing. I'm teasing.
Okay.
I was looking for the thumbs up, but I couldn't find it fast enough. Okay. Thank you.
No, it's a little, I know, it's a little, okay. So, here we are. Okay. I had to slow down one of my recordings to do some editing. And on a class recording it and edit something out. I showed a password I didn't mean to show. And oh my gosh, it's slow. It was hilarious. I sounded so drunk. Oh, all right. So let's start over here. All right. So this is the router advertisement from home. It's advertising this prefix. Okay, my device is going to take this network prefix and create a public IPv6 address. We're just going to look at public address right now. Okay, says, all right, let's create one that people from the outside, or Rick, you want to access this computer from the outside and do something, whatever? Yeah, you can do that. No NAT needed. Okay, let's grab that prefix, create an interface ID that's random. Now, lifetime. What? This is only good. I'm going to use the lifetimes from the public address uses the lifetimes from the router advertisement. What? This is only good for 5 minutes? Rick, I thought you said this was going to be good for a long time. Okay, I love this. Comcast says, yes, I made it short lifetimes. Why? Because what I'm going to do is this. So this lifetime starts at 300 seconds, and every second counts down to zero. Once it gets down to zero, it's gone. We can't use it anymore. Okay, but Comcast router goes, you know, what I'm going to do is I'm going to continue to send router advertisements before this gets down to zero. I've got 5 minutes to send you a router advertisement, and then you will refresh. As long as when you get a new router advertisement from me showing this same prefix, you'll go, oh, this prefix is still good. This means my address must still be good. And I can reset this lifetime back to 300. So it's going to count down. I do this again here. I'm going to count down from 300, 299, 298, 297. And guess what happens? The router sends a new router advertisement. Comcast sends this every 3 seconds. Every 3 seconds. Okay. Think about that. It only got down to 297. And what happens when it gets this new router advertisement with the same prefix? Well, this tells the client that this prefix, hey, it's still good. You can keep on using this address. Oh, my client goes, great. Let me just, and watch here. I'm going to reset this timer. 300, 299, 298, 297. And every 3 seconds, I'm going to send a new router advertisement that's going to say, this is still good. I can reset, sorry, this animation, 300, 299. You notice what's happening here? It's a little slow on Zoom. So every 3 seconds, router is sending out a new router advertisement message and the lifetime's being reset. Does that make sense? So it's staying good. Say, you're good, you're good, you're good. Matter of fact, it's got a lot of chances, even if it misses a few. You know, for whatever reason. 100 chances, but only good for 5 minutes, right? Right. Well, we'll see what happened. I'm going to answer this what if question coming up here in a moment. So yeah, and this is how Comcast decided to do it. And what it did, and this is a little, it set a relatively low lifetime because it says, I'm going to continue to send you router advertisements. Okay. And these don't take much. Okay. I think I showed you this when we looked at router advertisements in that discussion on Wireshark. There was a lot of them in Wireshark. Okay. So every time a router advertisement is received containing the same prefix, the client will reset the lifetime back to whatever it was told, 300 seconds. Start the countdown over. Okay. So this frequency, the constant router advertisement every 3 seconds, it tells the client, hey, this prefix is still good. I'm still here. We're still here. This network's still good. We're still good. We're still good. Because if I'm still here, you're still here, people can still reach you. Okay. So it's kind of cool. Okay. So this is still valid. Now, you may be wondering, oh, there's our countdown. Let it count down. We got a couple more. Counting down. This took me a long time to figure out. Not figure out, but get all this animation took a while. PowerPoint. Okay, counting down. Okay. Oh, but what happens, Rick, when my Mac or my Windows works the same way, by the way. What if I disconnect from the network? What do I mean disconnect? I'm going to be gone for more than 5 minutes. I'm not going to close my laptop. I'm going to go to school. I'm going to go to school for most of the day and then come home. Okay. What happens when I reconnect? Okay. Now, this is up to your operating system. Okay. This is up to the operating system. What would the operating system like to do? Mac and Windows does this. Okay. Again, your operating system is really in charge of all this. It says, you know what, what I'm going to do is I'm going to take, this public address. Okay. When I determine my public address, I'm actually going to cache it. I'm going to put it in non-volatile memory that I can save later. Okay. That doesn't go away. Okay. Well, if I reboot, it does. Okay, but I'm going to keep this. Well, if I reboot, it doesn't go away. I'm going to keep this. Let's just leave it at that. I'm going to keep this. I'm going to remember this. And so I disconnect from the network. Okay. All right, I'm gone at work. Okay. Come back. Much longer than 5 minutes. Okay. Come back with my cached public IPv6 address. Now what happens is I connect to my home network. My home network is still advertising the same prefix. As long as it's advertising the same prefix, my computer will say, I'm going to use that public IPv6 address that I used before. So this public IPv6 address could be indefinitely. So it's always there. Yeah. So that's the public address. And again, that's fine. We don't need that to change. Okay. Oops, so again, public address, we're going to stay with the lifetimes of the router advertisement, and as long as it's good, but I'll cache the address, so if I come back to that network later, I'm still using it. Okay. Now the temporary address, I have options. And before we get into those options, let's take a 5-minute break. Can't believe this goes by so fast, at least for Rick. Gosh. Okay. Let's take 5 minutes and then we come back and we'll talk about this. Bring this up. We'll do 8 minutes. I know people like 8 minutes, so we don't feel rushed. All right. Let me pause the recording.
Recording stopped.
Oh, give me 1 second here. Where's my power? go? There we go. Too many windows open. Thank you. Definitely. Thank you. Yes, let me do that right now.
Recording in progress.
All right. So public address, kind of straightforward. The operating system, the client operating system really has no problem with reusing the public address for as long as needed. And again, that public address is all about, let's go here again. Public address is all about being able to connect from the outside. Why we call it stable, permanent, it can be used via DHCP. It can be, you can create one from DHCP statically, or the one it creates from SLAAC. You can remove a public address and have it regenerate another one. So you have to look at your operating system on how to do that if it was generated via SLAAC. There's different ways you can actually do that kind of fairly easily if you want a new public address. The temporary address is one that the operating system is actually more concerned about. It wants to make sure there's a little bit more privacy. And that's these right here. These private addresses here, temporary addresses here. Wants a little bit more privacy for that. So let's look at the temporary address. Now I'm going to look at my home router first. Again, the operating system, it says, okay, I'm looking out for you here, Rick. Okay. Again, same prefix, same the lifetimes. Okay, there's not separate lifetimes for permanent and temporary. It's one set of lifetime that the router advertisement sends. So the router advertisement includes the prefix and these lifetimes. Now, when generating a temporary address, okay, it's going to create a random interface ID. This asterisk just means this is part of the privacy extension. You only have one choice with temporary. It's going to create a randomized interface ID. Okay, so there's our prefix, there's our randomized interface ID. Okay, the lifetimes are going to be ultimately up to the client OS what it wants to do. Okay, it can use its own lifetimes, or it can use what's in the router advertisement. When a router advertisement is received, it will reset the valid and preferred lifetimes, okay, of the temporary address. Okay. Alternatively, the client can choose, the client operating system, once it can choose to ignore the router advertisement and say, I'm going to set it initially to what you have, but every time I get a router advertisement, I'm not going to reset it. I'm going to let it count down to 0. What I'm getting at here is your operating system's looking out for you, and it's like, I'm going to do what's best, and always look out for you, whether or not I let it count down or reset. But I'm going to, every so often, don't worry, I'm going to be resetting this temporary address. Okay, so in this case here, notice the lifetime. So I'm at home, and it's actually being reset. So this temporary address, as long as I'm online, is being used. It's not a problem, as long as I'm connected. So, you know, now, from the perspective of Comcast, it says you're a home user, Rick, okay? This is not a server or anything that chances are you're gonna, be shutting down your computer or taking it with you, whatever. It's just a home computer, okay? Now, notice that this is a temporary address, and every time I kept on getting a router advertisement, it reset the lifetime. So my operating system says, okay, 300 seconds, 5 minutes, fine. And my operating systems, both Mac and Windows, says, every time I got a router advertisement, I'll reset it. No different from the public so far. Okay, no different. But this time, what happens if I disconnect and reconnect to the network? I turn off my computer, I unplug it, I take it with me to school and then come home. What happens? Okay. So I disconnect from the network. Now I reconnect to the network. Okay. Longer than the 5 minutes. Okay. I get a new router advertisement. If it's longer than the 300 seconds, it will actually create a new temporary address. It won't cache, doesn't cache. It says, no, you were disconnected for about 5 minutes, longer than 5 minutes. You're getting a new address. You did not have anything happening for 5 minutes. And now what that means is my computer, even if it was on, if it had no active connection for 5 minutes, okay, and that's kind of unusual. Your computer's usually chatting something, but was not talking to a website, was not any, it was not, if any active connections where it was actually using this address expired, okay, no longer valid, then that connection is no longer valid. Next time I turn on my computer, open up my computer, get out of sleep mode, I've got a new address. Okay. Now, just to throw this in there, Mac OS and Windows does something similar. They call it something different. It gives you a little leeway past 5 minutes. Okay, just so you know that, but not important. Okay, but what I'm getting at here is, let me back up here. After, if my computer is not actively talking to anybody for 5 minutes, either it's stopped, no more connections. I'm not listening to Spotify. I'm not watching a video or anything. It's just, not using this address for 5 minutes. I've shut down my computer. I've taken it elsewhere. Okay. I've got no active connection with that address anymore. When I come back, I'll get a new temporary address. Okay. Does that make sense? So that temporary address is temporary. Okay. That's where your privacy comes in. Because now, even if, let me go to a website here. Let me show you kind of an example. Let's go to Cabrillo's site here. Let me bring this up as a little example. Cabrillo's website. Okay. Now, what do I mean by this? Okay. So I'm connected to Cabrillo's website. Let's say this is my IPv6 address. I'm connected to Cabrillo. Okay. Okay. I'm connected to Cabrillo. Okay. let it, sorry, my animation. So all right. So let's say now, come on. Sorry. Okay, there we go. Now let's say that what happens if I no longer connected? So by the way, I'm looking at this website. You may think I'm connected to this website. I'm not. So let's think about, we're talking about TCP in my 81 class right now. And we just started talking about this. So let me bring this up. When I connected to Cabrillo initially, what happened was this TCP three-way handshake. And my operating system says, I have a connection with this server, and the server says, I have a connection with you. Okay, we exchanged some data. I gave it my request for the web page, and it sent me all of this. And we have a connection, but only for a little while. At some point, this server that's hosting Cabrillo's website is going to say, Rick, I'm not keeping track of you forever. At some point, Rick, I'm timing you out. Okay, you're cut. We've timed out the connection. Now it might be 10 minutes later. I come back and I look. It kind of looks like I'm still connected to Cabrillo. I'm not. What I'm looking at is in my local computer memory. I'm looking at this web page locally. Okay. I'm not really connected to it anymore. I once was, but not anymore. It timed me out. And I've been looking at it locally anyway, even when I had a connection. But at least it knew I was still around. Now it says, Rick, your history. So if I click on something, isn't this great? Fall 2024 classes. Jeez, people, get it together. Our website. I'm not the biggest fan sometimes of our website. All right. So why don't they bring up the new schedule? All right. So I click on that. Now it reestablished a connection. Now what I'm getting at is over here. That had timed out. Okay. So now when I made that new connection, what happened was I did it with a new address. Okay. So it's seeing me as a different address now. Okay. That's where kind of the privacy comes in. Okay. It says, oh, okay, I don't know, you're a different IP address connecting to me now. Does that make sense? Okay. Good. Yeah, I always like to throw in some real networking stuff that's beyond, it all comes together. All right, so let's talk about these lifetimes. Okay, so whenever you have an address gets created via SLAAC, stateless address auto configuration, it actually has these different states. First of all, it's in tentative state. We'll talk about that in a moment. I already did talk a little bit about that. Means I've got an address, but it's tentative. I need to make sure that there's no duplicate. We'll talk about that in a moment, but it says, hey, is anybody out there have this address? If I don't hear from you, then I know it's mine. I can ARP request. Okay, then it's going to go into a valid state. Now, we've seen just valid and preferred, but actually valid can be longer than the preferred. We'll talk about this. Okay, preferred means I can create new connections. Okay, so I can create a connection, and for whatever the preferred lifetime is. Okay, anytime I want to access a new website, I can use this address as long as it's still preferred. So there's a certain time that I can use this address for new connections. But after this preferred lifetime expires, it then goes into what's called deprecated state. Now, if I'm still using that address, I'm still using it, I'm watching Netflix, I'm listening to Spotify, Okay, I'm doing my banking. I can still use that address. Okay. All right. Uh, and I can use it until as long as I have an existing connection. Okay. All right. As long as it's still valid. Okay. But if there's no existing connection, meaning I was, I was using it. I'll show you an example here in a moment. We'll do a couple of examples here in a moment. But if there's no existing connection, the address will eventually come what's known as deprecated. Once it becomes, if no existing connection becomes deprecated, it means, so existing connections are okay. So it's now deprecated. I'll still use it. You're still listening to Spotify, but now you're in deprecated state. Okay? You're in a deprecated state. And I'm only going to use you while you're still, you're only good as long as I'm still using you. But as soon as that connection is no longer using that address, if it's gone past the preferred and into deprecated, then once you're done, you become invalid. I can't use that address I won't use it for any new connections. So this is where we see multiple addresses. We'll see an address that's preferred and one that's deprecated. Let me show you an example of such. I can actually, let me put this. One second here. Let me do this. Let me do my little analogy first. Here's my little analogy, and then I'll show you an example. Tentative. Tentative is like going to a restaurant and waiting that before you're seated, that your table's available, that nobody else is using your table. Okay? You're not seated yet, so you can't sit there, but they're making sure that nobody else is seated there. Okay? That there's no conflicts. Okay? Just like your address, nobody's using it. Okay, now you can use it. Preferred, you have the table. You can make orders, you can order more food, you can eat. Just like with a preferred address, you can make new connections. Let me go to Netflix, let me go to Zoom, let me go to Amazon, let me go to Google. Hey, that address is still good. Okay, now at some point, that address is not going to be good anymore. It's still going to be good, still going to be valid, but not for new connections. It's what we call deprecated. That address was allowed for new connections, but now it's reached a time when the operating system says this is deprecated. What does that mean? It means, hey, if you're eating, hey, finish your food. Not a problem. You can still eat your food and sit there, don't worry, okay? As far as like, if you're listening to Spotify, you're doing your banking, hey, it's no problem. If you're still using that address, you can continue to use it, okay? So that address is still valid. But when you're done with that address, when it's no longer being used to connect, let's say let's say you were listening to Spotify, okay? You're listening to music, okay? So it's now become deprecated, but you're still listening to music, no problem. Now, what happens when you go to a new website? This address is deprecated, but now you want to do your online banking. You have a new address that's preferred. So now you have two addresses. Kind of show you a quick example. So here I have one that is, it's kind of all over the map here. I have one that's a new temporary address, but one that's also been deprecated. So this deprecated address here is one that my computer it's no longer preferred. It says, nope, you're down, okay? But you can still be used. Now you're still listening to Spotify, not a problem. But for any new connections, I've created a new address for you, Rick. This address right here, this new temporary address. Use that one for new connections. So you got new connections, use this. But since you're still listening to Spotify, hey, I'm not getting rid of this. You're still using it. Does that make sense? This used to be preferred. Yeah, you were preferred at one time when you first connected to Spotify. You're fine. And maybe connected to some other websites. Hey, you used to be the preferred one. You were, for all new connections, you were preferred. But you're no longer using those connections. You're no longer on Cabrillo's website. You're no longer looking at Google. But you know what? You're still listening to Spotify. So you're deprecated and you're still okay for that. Okay. But if that's the last one that's the last thing this address is being used for, once you stop using it, you're no longer preferred. Once you stop listening to Spotify, you're gone. Okay. Does that mean no IPv6? No. Before I deprecated this, I created, here it is, a new temporary address for you. And this one you can use now. Keeps the price, and what's different about these? Well, notice that the network is the same. What's different is the interface ID. It's changing it. Okay? It's changing it. Okay, now that's up to your operating system how long it will wait. Okay, to change it. I'll show you an example here in a moment, and we'll be closing with that. Okay, but eventually, when this address, I'm no longer listening to Spotify because it's deprecated and nothing else that I was using this address for when it was preferred. And if it became deprecated, like Spotify, hey, I'm still listening. But if nobody else is using that anymore, this address will go away once I'm done with Spotify. Okay. So valid just means, yeah, you're preferred. Hey, you can order food, or you're somebody that is still you're still hanging on. You're going to have, if you have a deprecated address, you're going to also have a preferred address. You're going to have both. Okay. Eventually, though, that address will become invalid and removed. Let me show you an example here. Let's talk about tentative real quick here. Tentative is just making sure that it's unique. For example, when your computer first connects to the network, okay, it gives itself a link local address. It says, how do I know that's unique? How do I know this interface ID is unique? Well, it sends out equivalent to an ARP request called a neighbor solicitation. It says, whoever out there has this link local address, send me your MAC address. And it's going to set a timer. It's hoping what? Nobody replies, right? Hopefully nobody sends back what's called a neighbor advertisement and says, yeah, that's my IPv6 address. Let me give you my MAC address. No, it doesn't want that. If it does, then it knows, oh, you're not unique. Wow, that's weird. All right, well, I'll just create myself a different link local address. Okay. This used to be required that it did. This is called duplicate address detection, DAD. It is no longer required, okay? But operating systems still do it. Matter of fact, you'll see when I've been doing ifconfig here, it says right there, my interface does duplicate address detection on these addresses, making sure nobody else is using them. Okay. what I want to show you. Yeah, so this, let's see, let me get to where I'd like to show you an example. Okay, here's a little example here. Yesterday, I came to work, came to school. My computer got this public IPv6 address, okay, that it probably has been using for a long time. The lifetimes are reset, it's cached, and then reset by the router advertisement. Let's see, I gotta show you the router advertisement here. Yeah, that's where I gotta back up here. Sorry. All right, let's see if I can do this here relatively quickly here. I'm gonna show you how this works on Cisco iOS here at school. Okay, this is our prefix. The router advertisement says has a valid lifetime for 30 days. Preferred lifetime of 7 days. That's a long time. My operating system says, okay, for public address, I trust you. This public address will be good for 30 days. Be preferred for 7 days, but good for 30 days as long as I keep on getting router advertisement messages. We won't get into that right now. But my Mac operating system says, you know, that's a long time. For temporary address, I'm going to modify it to a shorter time. The preferred for temporary addresses, you're only good for 24 hours. Preferred. You'll be valid for 7 days. I mean, if Rick is listening to Spotify for 7 days, I'll keep you active. But so that's a long time, by the way. But 24 hours is how long you're going to be preferred for. So let's I'm going to jump ahead here and show you so we can. So I don't want to beat a dead horse on this, but I want to show you the example of me coming to work. So I came to work yesterday and my public address, not a problem. If I wanted to connect to this computer from the outside or somebody did, this address has been around for a long time, set by the router advertisement and continually set. So that's going to be pretty much permanent. Here's my temporary address. Now, it says it is preferred for about 24 hours. I just logged in, 23 hours, 47 minutes. Just got this address, okay? But it's only good, it's good for just under 24 hours. 10 hours later, I'm about ready to go home. I look at this temporary address. We don't have to worry about this public address. It says, Rick, you're good for another 13, this address is good, preferred for another 13 hours. Okay. Now, if I happen to be listening to Spotify, after those 13 hours expires, you can keep on using this address if you're connected to something for the next 6.5 days. That's pretty long. I think I would change these on Cisco iOS. We just may do that. Okay. But these are the defaults. No real reason to change it, but you saw Comcast, boy, 5 minutes. Look at this. 24 hours instead of 5 minutes. 7 days instead of 5 minutes. Okay. And why does Cisco use those lifetimes of 24 hours and 7 days for temporary addresses? Because that's what it defaulted to years ago. You know, you change that default, you could be changing what, you've got to let, this is an enterprise stuff. You got to let them know, hey, I've changed the defaults, okay? I think at this point, as an enterprise IT person, I would set my own defaults. You can set what times you want these to be. The defaults are 24 hours for preferred. So what does that mean, Rick? So here I'm at 13 hours. If I'm just here at work and I'm listening to Spotify via IPv6. And I never turn off my computer. I stay connected. For the next 6.5 days, I can be listening to Spotify. But I did. I went home. Okay. All right. So 15.5 hours later, I came back. This preferred lifetime expired. It was good for 13 hours, almost 14 hours. I came back 15.5 hours later. My public address is the same. Got the router advertisement message. My computer says, yeah, you're still good. It's used the same public address. But notice I have a new temporary address. This is because my preferred lifetime expired. And so I'm not going to create any new connections. Matter of fact, since nothing is using that address, it's been deleted. It's no longer there. And I got a new temporary address. Okay. So when I came in this morning, okay, it just gave me a new temporary address. Okay. And as long as, this address, was only, it counted down for 24 hours. And as long as, and it says, hey, after that, it's not going to be good anymore. Now, what if this happened? Do you have 5 minutes? And I can let me, yeah, give me just 5 minutes here. What if I came in well, let's do this. I'm not going to keep you because I'm going to go down a little bit of a rabbit hole and I don't want to. So I want you what I want you to get from this is that the operating system is going to do what it wants to do. Okay. I do have a little bit of a summary. Let's talk about this really quick here. Public and temporary addresses. Public addresses. It uses the prefix, the valid and preferred lifetimes to create a public address. No problem. It did the same thing for a temporary address, Windows and Mac. Creates a temporary address using the prefix and the lifetimes. And also randomized ID has to do that. Here, randomized ID is preferred. Okay, why, could use EUI64, but randomized is preferred. Okay, no problem creation. The refreshing. We saw as long as it's getting the router advertisement, this public address says, hey, you're still good. I will still belong to that network. Okay. Matter of fact, I'll even cache it if on my computer and reuse that public address next time I reconnect. Temporary addresses, the lifetimes are reset by the RA as long as it router advertisement, as long as it contains the same prefix. However, it's up to the operating system on really how long, if it wants to use the lifetimes. It says, with Cisco iOS, you're just way too long. My operating system says, I'm going to create shorter lifetimes. Okay. I'm not going to reset it every time. If you noticed up here, every time we got the router advertisement, the router advertisement sent every 3.5 minutes. It did not reset the timer. It says, I'm going to eventually let you expire. Okay. And what happens if this expires and it's still being used by Spotify? No problem. You're deprecated for a while, and I'll just create a new one. So that's what I want to get at here, is just know that whenever you see a deprecated address, you also have one that is now preferred. See the preferred lifetime here? You're good. That's PL, preferred lifetime. Notice my deprecated address here, preferred lifetime is 0. You're not going to be used by new addresses. You're just a hang on. You're hanging around until you no longer use because something is using you. But as soon as you became deprecated, before you became deprecated, I actually created a new preferred one. Okay, so they'll rotate. You only see deprecated when there's something that is hanging on. So, the new temporary addresses will always be created by your operating system. Okay. But don't worry, it won't cut you off from something that you're using. It'll just make it deprecated until it's no longer needed. Does that make sense? That's kind of it. The only, and don't worry about the timing. 5 minutes, how long? You just got to look at what you just become familiar with your network. Okay, it's going to rotate these temporary addresses. But don't worry, it will keep one deprecated as long as you're using it. But as soon as it's done, it's gone. Okay, but you'll always be getting new preferred addresses, temporary ones, okay, to keep you private. Okay, so when you're in, and again, this is being used when you initiate connections to other devices, so they can't keep track of you. Okay, very cool, very cool. Okay, so this is how it hides you. Okay, that you're kept hidden. It doesn't know really who you are. Okay, we talk about NAT and private IPv4 addresses. Ooh, you remain private, hidden. This does a better job. Because there's actually ways you can get in via, find out who it is via, even when they're using NAT. All right, I'll let you go. This was a mind bender, I know. So we'll get to something a little bit more. Actually, now we're going to get to, a little bit more, not as much as a mind bender as this. We're going to talk about DHCP on Thursday. And then we're going to talk a little bit more about multicast addresses next week. But this is what IT people like, that seasoned IT people, just like their eyes gloss over. My eyes gloss over too. I just have to look at this and go, okay, what's it doing? What's the router advertisement message? What's happening here? What's the operating system wanting to do? Again, and I'm sorry, I'm just going on and on here. The public IP address, hey, use it as long as you need it, okay? But this temporary addresses are just going to be, they only have a certain lifetime. At some point, it's going to become deprecated if I'm still got an existing connection, and I'll create a new temporary address for you to be used for new connections. All right, I'll let you go. Thanks for hanging out. Thanks for listening to all this. And I will see you on Thursday. Some of you I'll see tomorrow.
Thanks.
Have a good day, everybody. Thanks.
Thanks.
Thank you.
Rick?
Yes.
Tomorrow,
Recording
remember,
stopped.
I won't be in class, but I'll follow